Hello, my name is Peter Phelps with Phelps 3D, and in this FreeCAD 0.16 lesson I'm going to talk about designing threads. Thread design in 3D printing is probably one of the most difficult things a person is going to try to challenge themselves with. And sometimes it can be just variations in different 3D printers come out with slightly different results. But I'm going to say thank you to all those who have contributed in the FreeCAD forums and on the YouTube videos on this topic. There's probably 3 different methodologies out there. I'm only going to cover the one that works for me because the others I could not figure out, basically. So I'm hoping this is simple enough for most people. Now, if you're trying to do a thread project, what I would suggest is trying to design something simple first, small, that you can 3D print. Like this is just a basic nut on a bolt that I designed so that I could test it out. If you rather, you could connect it to a regular project and then use NetFab to just slice the parts that are necessary to test the threads, so that you're not wasting a whole lot of plastic when you're trying to experiment with the design to get it to work right. So that's the basic principle here is get your threads working the way you want them, so that they're tight enough or loose enough so that they mesh right after they've been 3D printed, before trying to print out your entire big project. Now, I'll go back to that later, but that's where my mouse. Okay. This is another product I made. It's a coffee creamer caddy design. So it has 3 pieces, one long threaded shaft, and then the other 3 pieces have matching threads in the holes so that it can be screwed together. In this case, again, like I said, I started out with something I already tried out, just a small portion of, and then designed out. Now, if you're trying to do up a 3D print that has to match some other threads that were already tapped into something else, or you're trying to match exactly to some other mechanical part, I would definitely suggest trying to get a couple of tap and die sets. These are the gauges that they use. These gauges will help you determine what pitch to have the threads at, and basically they can be placed on to a bolt to figure out what their threads are. Now, because I'm mostly using metric, I use the metric nut bolt one for this example. But once you have this, like that one, the pitch is 1.0 millimeters. Thus, that can be the pitch of the used to create the threads, or the part to try to fit the threads. Now, I have actually done this on a project for a lady who came into the Arcade Libraries design spot. That's part of the Sacramento Public Library's Library of Things program. Me and one of the volunteers there worked on her project, which was basically a leveling foot for her sewing machine table. And so we started out by using the metric gauge here to measure her broken plastic part, and we're able to replicate it based on these numbers. But it did take like 2 or 3 tries of playing around with the triangle to get it just right. There's many different types of profiles. And that's one of the first things I guess I'll discuss when I get into this. So I'll close that out. We're in part design. So I'm just going to switch over to part. And then I'm going to create a new document. And under the other primitives, if you click in here, you want the helix, and I'm going to make it, for our example, a pretty wide pitch. I'm going to say 3 millimeters. And I'm going to make this here about 20 millimeters high and a radius of 5. And say create. Notice here there is right-handed and if you wanted left-handed, so you can make right and left-handed threads. And I'll go create. And I'll close it. And then I'm going to change this to 3D view so you can see. Now the helix is just a 2-dimensional object. It created this basic what we'll use as the thread pattern for our object. Now I'm going to switch over to side view. You can see how it turns and spins around. And then I'm going to go back over to part design. And I'm going to create a sketch. And we want the XZ plane right now. Say OK. And we want to zoom in because we're going to want to look at the edge here. Now, you don't want to make the thread the profile of the thread exactly the same height as the helix from one point to the next. It should be just slightly smaller. And the profiles are basically what you create threads with. Now you do want to make sure you're touching the edge of the helix there, and like I said, just slightly smaller. And now you can have all sorts of different lengths of profiles of threads. I suggest not going further than the same as the height. But I'm going to go slightly smaller and just make it 2. And now this is the most typical style you're going to probably find as far as it being a triangle. But you can also have ones that are rounded. You can have ones that have, I think the Acme threads, they come out and they're square at the top and then they come back. So you can find all sorts of different profiles for the threads. If you're designing for other things, you'll want to measure and try to figure out whether it's a rounded one and how much to make it round, or if it's more like the Acme. It's like things like some of your water bottles or juice bottles, they'll use a more square, it'll be a squared off tip to the thread. Some of them also use that more rounded looking thread. So like I said, you don't really want to touch the next line. That will cause issues when the thread is made. I'm going to go ahead and click close. And then we're going to go back over to part. Maybe I'll zoom out. Back over to part. And then what we're going to do is we're going to sweep the sketch around the helix. So we're going to click the sketch. And put it on the other side. Go create solid, Frenet. I hope that's how it's pronounced. Now what I do is I go back over to the model. I click the helix to select it. And I go back over to tasks and say OK. And there you've just generated your threads. Now if you want to, you can make the sketch. Now select it, press space bar, select the helix, press space bar. Now if you want to try to make semi-matching threads, I click the helix, go control copy, control V, bring it back up so you can see it, but we're going to change the radius, and I'm going to go out 2 millimeters, so it will be 7, and then I'm going to take and change the placement of it slightly, so that it's, well, actually we should do it right there, probably. Yeah, we'll leave it there. So it looks like when I move it out towards my one. Now the tricky part with this, we're going to switch back over to part design, create a sketch. XZ plane. Okay. Zoom in. The tricky part here is to make a triangle that is slightly smaller than the other triangle that we just made. A little more. And as long as the triangle touches this edge here, we're good. So you want to make it slightly smaller bend the other triangle. So what we're doing is we're trying to create a matching thread for the hole of whatever this is threading into. So close that. Zoom back out. And we're going to do another one of those sweeps. We're going to go back over to part. We're going to take and sweep. This time we're going to take the new sketch, create solid, then it, go over to model, click the other helix we just created. That will select all helix, and say OK. Now you've got two hopefully matching sets of threads, and we're going to create a cylinder. Go back in and hide the sketch and helix. I sometimes wish it would automatically do that for me when I create different things. But it should already know that I don't want to see what was originally in there. And I'm going to make the cylinder radius same as we made the original. And then we're going to make this 20, let's say 25, and bring it down. Want the top to be even with the last bit of thread. Now we go to 2.25 down. And then if you want, you can create a prism radius and go and right and go for create code. And I'm going to take and move that one down so it's close to that. And what we're going to do is we're going to make another cylinder. I'm just going to copy the original first cylinder. So Control C, Control E, Control C, E, I'm going to drop that one down to -5, and then I'm going to make it taller, say 30. Oops, 30. And then I'm going to make that one the 7. Now this should match the second outer set of threads that we created. And so I'm going to take the prism, and I'm going to control, click that cylinder, and I'm going to make a cut. Okay. Now, you may be wondering, why didn't I just take the original threads and cut them directly from this prism? The issue with trying to do that is that it will be way too tight. If you attempt to put the threads together that way without making any gap between them, you won't be able to thread the parts together when it's 3D printed. And just because of the variations of how we're making 3D prints and the plastic and how it extrudes, etc., if you don't add any gap in there, you're going to end up with two parts that just will not come together. Now, you may have to play with those triangles a little bit, like I was saying earlier, to get it so that the tolerance works well enough when you actually physically print the thing on your 3D printer. And there's a lot of things that can affect that. What resolution you print at. The lower the resolution, the tighter the part might be. The higher the resolution, the more space you may need. So that's why I don't try to just cut it directly. And a lot of times, sometimes it doesn't even work. You try to make that cut and the program just doesn't like it at all. It'll make the part just totally disappear or go black. When it goes black like that, you don't want to try to print that. It won't work. And then this here may or may not work when you try to fuse it or not. Because the sweep and like the cylinder, you're trying to put together two surfaces that are basically the same surface. Sometimes the program doesn't know which should belong to which. I'm sure there's a huge mathematical equation explanation for why it may not work, but I would try to fuse it. If it doesn't, don't worry about it. The MakerBots, as long as the two are the same surface, the MakerBot won't mind, won't care, it won't try to create a separation between the thread and the part. So what I'm going to do is I'm going to try to see whether or not we can combine the cut we just made with the second sweep. That may take a while because of what the thread's geometry is. Okay, and that succeeded. So then we're going to do the same thing. Actually, I should probably give us some sort of surface for that middle. I'm going to make the cylinder here a little longer. Let's make it 30 and then bring it down a bit. Make that a 7. And then what I'm going to do is copy that, and then I'm going to make that one 4 and change the radius to 10 wide. And what I'm going to do, it's going to seem funny, but I'm going to copy the cylinder in. Control copy, Control C for copy, Control E for paste. And I'm going to change the radius to 1. And I'll leave the height where it's at. Then I'm going to move it on X. Let's say it was 10. Okay. I'm going to show you a quick way that we do. We can use the array tool to make sort of a knurled knob, or a knob that's easy to turn. So I'm going to go Part, Draft, and then I'm going to take that cylinder and I want to go array. This one here. And instead of ortho, you want to change it to polar. So instead of ortho, change it to polar. And then I'm going to say I want 10 of those. Enter. And then I'm going to tell draft I don't want the grid. Return back over to part. And then I'm going to take the cylinder, control click the array, and do a cut. So that we have little grip holes. That. And so now I'm going to take the sweep, the cylinder, and the cut we just made, and I'm going to fuse those together. Okay, and I'm going to rename these so that I know which is which. If you right click on it, or hit F2, you say rename, and this is going to be bolt. And then the other one, and this is going to be nut. If you want, you can change the colors of the parts too to help you differentiate each one. Say and you can take and change their positions if you want, or you really want to take a good look at the objects and how they overlap, and change the transparency. I like to say 50. So that way you can like look through it. Come on. I'm not sure if this is the computer just being really slow or if my mouse isn't clicking. Okay, so we can sit there. File, save. Just call this nut and bolt. And then select each part, probably put them out separately. Make sure your save type is STL mesh. Save. File. Export. And we'll open up. Netfab. So far, all I've shown you is loading one part at a time. You can actually load both of them. Still. Okay, and this shows no problem with it. Fun thing with this is it will put it just like I just had it. Bolt, STL. And no problems with both of those, so they should be 3D printable. And like I said, you may have to play around with the triangles to make it mesh completely right. I tried to have a certain amount of space in there, but there's no real super tight formula for that will work for just about all 3D printers. It depends on your printer, what the resolution you're printing at. Now, when I print this type of stuff, I definitely like to print at 0.1 millimeters to make the threads as tight as possible and on my FDM printers. So that's it for how to create a thread in FreeCAD 16. Thank you for watching.